Okay, so if we flip over on the back, we're going to see if we can figure out some things. Now, do we know what the degree of a function is? Remember?
What power is that?
Yeah, the highest power. So, like, if it's a quadratic, the degree is 2, because the highest power is 2. If it's a cubic, the highest power would be 3. A quartic would be 4. A quintic would be 5, and so on. So what do we notice about the sum of the multiplicities of the zeros and the degree? So let's look at this first one. All the zeros have a multiplicity of 1. So how many multiplicities does f of x have when I add them all up?
1.
Yeah, 1 for each one, so that's a total of 3. Because this one has 1, this one has 1, and that one has 1. So a total of 3. And what's the degree of this function? 3. Okay. And g of x, this one had a multiplicity of 1, and this one had a multiplicity of 3. So if I put those together, it has a total of how much? 4. And what's the degree of this one? 4. This one is 1. Multiplicity was 1. This one was 1. And this one was 2. And if I add all those up, what do I get? 5. And in quintic, it has the degree of what? 5. So, what we should notice is the degree equals the sum, and when you add up, of the multiplicities of the zeros. Okay, describe the behavior of the graph as it approaches a zero whose multiplicity is 1. So all of these black dots had a multiplicity of 1. What happens on the graph if they have a multiplicity of 1?
They just go straight through it.
They just go straight through it. Yeah. They don't, that bounce that we talked about. There's no bounce. It just goes straight through it. That's exactly right. Now we're going to use some different terminology here, but that's exactly what it is. The graph will cross the x-axis and not change concavity. And I'm going to explain to you what concavity is. When you're talking about concavity, if it's concave up, then it looks like the U in the word up. It goes this way. And if it's concave down, then it looks like the N in the word down. So if it doesn't change concavity, then the graph is, it continues. Like you said, it just keeps going. If it changed concavity, then it would hit the point and then go the other way. So like here, it might be concave up, up, and then it might go to concave down. So while it still goes through it, it changes concavity. So this is a change, and this one is no change. And we'll do a lot more of those. Number 3, describe the behavior of the graph as it approaches a 0 whose multiplicity is 2. So that purple dot right there is the only one we had that was a multiplicity of 2. What happens? It bounces. That's what we call it. It's a bounce. And this one is concave down, but it could also be concave up. It would work. The way it's described also is it's tangent to the x-axis, meaning it touches the x-axis at that one point and then goes off in the other direction. Like you said, it bounces. So the graph will be tangent to the x-axis. And I'm also going to write over here bounce. Because where you're reading your notes, you may say tangent and be like, what? But bounce, you'll probably have more of an understanding what you mean by that. Okay, and then number 4 is describe the behavior of the graph as it approaches a 0 whose multiplicity is 3. So the multiplicity, the only one that we had that was 3 was this one. And compare it to the negative 2.5 here. They both go through it, but how is the red one different than the white one?
It doesn't change in the opposite direction.
Okay, yeah, okay, I never thought about that, yeah. It's like tangent up here and then tangent from up here. Yeah, I like that. Anybody else describing it in any other ways? Okay, one of the ways it's going to be described to you is it's changing concavity. So like here, see how that yellow is concave down? And then after the red dot, it goes this way, and then that becomes concave up. So if it changes concavity, then it has a multiplicity of 3. And as you can imagine, this is going to help us graph these later. Whoa. There we go. The graph will cross the x-axis and will change concavity. Another thing that I hear people say is it flattens out. So like it's going and then it flattens out and then keeps going. So like right in here it flattens out. So that's kind of like Jenna was saying, it looked like it was constant for a while. It looked like it was 0 for a few points. That's because it had a multiplicity of 3. Okay, so for each of the following functions, you are given a factor. We're going to identify the 0 on the picture, and then use synthetic division to determine how many times the given factor is a factor of the function, and then that'll tell us the multiplicity, and then describe what the behavior is doing.